naught, which is average concentration function, rho naught. Rho naught is obviously total number of atoms in the specimen divided by the total volume of the specimen. So we add and subtract rho naught to rho r. So we do that. So we add and subtract. So here is the term which we have subtracted. So by definition, rho naught is the average uh, average uh, average atomic concentration. Average means total number of atoms in the specimen divided by the total volume. So हमने वहाँ पे रो नॉट ऐड किया और रो नॉट सब्ट्रैक्ट कर दिया. रो नोट जो सब्ट्रैक्ट किया जहाँ टर्म रख ली, जो ऐड किया वो टर्म हमने सेपरेटली लिख ली, वो टर्म हमने सेपरेटली लिख ली. नाउ वी कैन चेक दैट because our sample is basically macroscopic, so we can take this limit r tending to infinity. So limit r going to infinity, rho naught, it can be seen that this integral dr 4 pi r square sine kr by kr is basically rho naught delta k, where delta k is a three-dimensional Dirac delta function. So you can how because you can check it here, क्योंकि आप इस इंटीग्रल को दोबारा लिख सकते हैं कैसे, डी आर थ्री dimensional and this exponential iota k dot r. आप चाहे कॉपी पर लिख लीजिए. ये जो टर्म है इसको आप कैसे लिख सकते हैं, आप लिखिए कॉपी पे. इट कैन बी रिटन एज रो नॉट इंटीग्रल एंड लिखिए डी आर, आर के ऊपर वेक्टर, एंड देन एक्सपोनेंशियल आयोटा कैपिटल के वेक्टर डॉट आर वेक्टर. ये आपका जो इंटीग्रल है, इसमें जब आप एंगुलर इंटीग्रेशन करेंगे तो एंगुलर इंटीग्रेशन करके आपका यही आ जाएगा. तो अगर आप उस इंटीग्रल को देखें, दैट इज नथिंग बट डेल्टा के, डायराक डेल्टा फंक्शन. सो एज यू कैन सी, this Dirac delta function is non-zero for k. It is this Dirac delta function is zero for k not equal to zero. That is, it is non-zero only when capital K is zero. Capital K is zero. So it means this is negligible. Capital K recall कीजिए, capital K क्या था, delta K. Delta K क्या था, K dash minus K. So capital K zero mean K dash is equal to K. That is your forward scattering direction. So it means this second term here in this expression is negligible except in forward direction, क्योंकि forward direction में delta K आपका non zero है. Forward direction mean capital K equal to zero. Capital K equal to zero mean K dash is equal to K. तो उस एक डायरेक्शन को छोड़ करके ये जो सेकंड टर्म है जहां पे इस इंटीग्रल में, दैट इज नेग्लिजिबल. सो देयरफॉर वी इग्नोर दिस टर्म, सेकंड टर्म. सो इफ वी इग्नोर दिस, कैपिटल आई just becomes nf square 1 plus this as it is dr 4 pi r square rho r minus rho naught sin kr by kr. हमने ये जो सेकंड टर्म थी इसको इग्नोर कर दिया क्योंकि ये टर्म नेग्लिजिबल है except in the forward scattering direction. Okay, now what we do, we introduce a quantity called structure factor of the amorphous solid. Remember, you should notice here that this structure factor is not the same as we have come across earlier while discussing the structure of a crystalline solid, but this structure factor is defined as scattered X-ray intensity divided by NF square. So obviously by definition you can see it is just scattered X-ray intensity, I divided by NF square, which is just a constant, NF square. Okay, so we introduce a quantity here, scattered X-ray intensity divided by NF square, and call that as structure factor of the amorphous or the non-crystalline solid, So clearly I divided by nf square is given by this expression, is given by this expression. This is an important expression because we experimentally know I as a function of capital K. Capital K क्या है आपका? डेल्टा K के बराबर है, यानी we know I as a function of angle of scattering, क्योंकि K में सीधा सीधा angle of scattering है. So why it means this SK uh, is an experimental quantity, because it's defined as scattered X-ray intensity divided by NF square. Now at this stage we introduce the radial distribution function, which I mentioned in the very beginning. So we introduce a function called radial distribution function and denoted by GR. So by definition, the atomic concentration function rho r is equal to GR multiplied by rho naught. I recall here what is rho naught. Rho naught is the average atomic density. So you multiply the average atomic density by a function which I have called as radial distribution function. You get the atomic concentration function. It means this quantity GR basically decides how the actual atomic concentration is different from the average atomic concentration. एक तो आपकी एवरेज एटॉमिक कंसंट्रेशन है, उसका वैल्यू थ्रू आउट द सॉलिड सेम है, इट्स ए कांस्टेंट. उसको आप कैसी एक फंक्शन से मल्टीप्लाई करें ताकि हमें एटॉमिक कंसंट्रेशन फंक्शन मिल जाए, तो उस फंक्शन का नाम ही रेडियल डिस्ट्रीब्यूशन फंक्शन है. इट मींस द रेडियल डिस्ट्रीब्यूशन फंक्शन बाय इट्स डेफिनेशन contains information about the radial distribution of atoms in the solid, that is non-crystalline solid. So this so you substitute this rho r in terms of gr. Therefore the liquid structure factor, if this is liquid or amorphous material structure factor, becomes Sk equal to 1 plus this 4 pi rho naught. We take common and take it out, 0 to infinity. So we have substituted this rho r in terms of gr. So we get this. So we get this relation. So which by definition this gr has spherical symmetry. That is, it depends only on the magnitude of r. Okay. So Sk is equal to, therefore, this one, and we can rewrite this as in this form, exponential iota k dot r. How this can be written? You can carry out the r integration, और r integration में आप theta और phi का integration कर लीजिए, you get back this 4 pi and all that. So this can be written in this form. Now you should check that this form is, so Sk is clearly a quantity in the Fourier space. Sk is a quantity in the Fourier space, and gr is a quantity in the real space. So this relation basically it gives you Sk is just the Fourier transform of this gr minus 1. So by using inverse Fourier transform, one can write gr minus 1 in terms of Sk. So that we do by using the inverse Fourier transform, gr minus 1 is obtained like this. Okay, it means the radial distribution function that we have introduced can be written in this way. Now Sk is an experimental quantity. We know S as a function of K. That is, we know scattered X-ray intensity as a function of angle of scattering. So that data we substitute here. Sk, source of Sk is experiment on XRD from non-crystalline solid. So we know Sk. So use that Sk here. This gr can be obtained. It means we can describe the structure of the non-crystalline solid in terms of the quantity which we have introduced, and that quantity is your radial distribution function. That quantity is radial distribution function. So by definition, you can see you multiply the average atomic density in the solid, with this function, we get the atomic electron concentration function. It means GR tells us the way how the atoms are distributed in the real space in the non-crystalline solid. In the non-crystalline solid, of course, it is a function of R only. Angles have been averaged out. Angles have been averaged out. So, so it means from the experimentally measured structure factor Sk, which is intensity divided by Nf square, the radial distribution function Gr can be calculated. So it means the conclusion is that we can describe the structure uh, of a non-crystalline solid in terms of the quantity called radial distribution function. Radial distribution function is related to the scattered X-ray intensity by the relation 23, where Sk is the liquid state or the amorphous state structure factor. So here in this figure, I've taken this figure from Kittel. By the way, this topic is in chapter 17 of Kittel. ये जो topic है non-crystalline, ये chapter 17 है Kittel का, उसमें है. So here is a figure for liquid sodium. Here is a curve for liquid sodium. So liquid sodium, as the name suggests, it is the sodium in liquid state. So in liquids, as you know, there is only short range order. So typical example of an amorphous material. So it contains three set of curves. Here is a plot between 4 pi r square rho r. You know rho r is given by gr into r, rho naught. So gr कहाँ से निकालेंगे आप? जो आपने एक्सपेरिमेंट परफॉर्म किया, एक्सरे डाइफ्रैक्शन का जो आपने एक्सपेरिमेंट परफॉर्म किया, वहां से हमें आपको एस के मिला एज ए फंक्शन ऑफ के. इसको इंटीग्रेट कीजिए, यू गेट जी आर. यू गेट जी आर. जी आर आप जहां सब्स्टिट्यूट करें, यू गेट रो आर. रो आर. तो there are two curves shown here. One is curve B. This curve B is just 4 pi r square multiplied by rho naught. So as you know, rho naught is independent of r. So it's just a parabola. It's just a parabola that is taken as a reference. That is taken as a reference. Now you see this curve. The curve A is the curve which is based upon the experimental data of Sk, and from there you get Gr, and then that Gr is substituted in rho r. So we get this curve. We get this curve, this one. So now you can see that there is some structure here at short range, but then there is no structure. Then there is no major structure. So there is only short range order. There is a peak here. This peak indicates that atomic concentration function is, you see, is peaked here, and then there is a dip also, but then it is increases, and then there is no pattern. Then there is no pattern. So it's clear from here that there is only short range order. There is only short range order in a non-crystalline solid. So these lines, which bear some numbers 8, 6, these are just the lines corresponding to the crystalline sodium, sodium in the crystalline state, sodium in the crystalline state. So if you look at structure factor, which is this Sk, which is liquid structure factor, which is scattered X-ray intensity, and I have not drawn that figure here. If you see that chapter 17 of Kittel, there is scattered X-ray intensity plotted as a function of scattering angle. So that scattered X-ray intensity contains a single broad peak, a single broad peak. So it means in the non-crystalline solid, do not get Bragg lines, which are it means at certain directions of scattering, the scattered X-ray intensity is maximum in case of crystalline solid, but in case of non-crystalline solid, you get only one or two peaks at most, but those peaks are not sharply defined, and those peaks are narrow peaks. Those peaks are narrow peaks. I think with this, our discussion on non-crystalline solids is complete, and also first unit is complete. So from the next lecture, I will start with unit 3, which is on band theory of solids, an important topic. An important topic, as you must have realized by now that electronic energy bands play important role as far as the electronic properties or optical properties, or some other properties of the solids are concerned. So from the next lecture, I will start with, you see, I will start with unit 3. I will start with unit 3. I will ask you one thing in the meantime. Just go through, because still you have uh, 1 week. Uh, just go through chapter 6 of the book of किचन. उसमें जो चैप्टर 6 है उस बुक का, उसका टाइटल है फ्री इलेक्ट्रॉन फर्मी गैस. फ्री इलेक्ट्रॉन फर्मी गैस, इसके बारे में पढ़ लें. पर्टिकुलरली जो आपकी फ्री इलेक्ट्रॉन गैस इन 3 डायमेंशंस वाला टॉपिक पढ़ें, और उसमें आप देखेंगे कि फर्मी एनर्जी क्या होती है, फर्मी वेव वेक्टर क्या होता है, फर्मी वेलोसिटी क्या होती है, फर्मी स्फीयर क्या होता है, डेंसिटी ऑफ इलेक्ट्रॉन स्टेट्स क्या होता है. तो पर्टिकुलरली ये टॉपिक जरूर पढ़ें. और अगर टाइम लगे थोड़ा सा तो आप हीट कैपेसिटी ऑफ द इलेक्ट्रॉन गैस, डिटेल में नहीं, क्वालिटेटिवली, कि इलेक्ट्रॉन गैस का हीट कैपेसिटी कैसे आता है. पर्टिकुलरली अगर आप क्लासिकल मैकेनिक्स के लॉज अप्लाई करने की कोशिश करते हैं तो कैसे आपके रिजल्ट्स एक्सपेरिमेंट से ऑफ हो जाते हैं. तो ये आप चैप्टर 6 जो है फ्री इलेक्ट्रॉन फर्मी गैस, इसके बारे में थोड़ा पढ़ें. हाँ, क्योंकि हम जो है हमारे सिलेबस में जो है हम सीधा ही शुरू करेंगे फेलियर्स ऑफ द फ्री इलेक्ट्रॉन फर्मी गैस मॉडल, कि उस मॉडल के क्या फेलियर्स थे. तो उन फेलियर्स को डिस्कस करते हुए हम देखेंगे कैसे आपकी जो बैंड थ्योरी ऑफ सॉलिड्स हैं उसमें वो फेलियर्स रिमूव हो जाते हैं. उसमें जो फेलियर्स रिमूव हो जाते हैं. आई थिंक with this I stop. With this I stop. Okay.